All right, last question. I can tell at a glance that I'm going to need the quadratic formula for this question. I didn't get that by reading the question at all. I got that by reading the answers. You see the plus minuses in your answers? That's what gives it away that we're looking for to use the quadratic formula. And before you run for your calculator, keep in mind that the quadratic formula is almost always asked. In fact, as far as I know, as far as I've seen, it's always been asked in section 3 of the SAT, meaning you're not permitted to use your calculator. So it would be great if you have a program into that TI-86 or TI, or whatever graphing calculator you prefer. But it's not going to help you in this one because this is going to be a section 3 question. So I'm going to go right ahead and use the quadratic formula, but there's one thing I'm going to check before I start, and I am going to check for GCF. And there is one here. It's going to make all of the math a lot easier for me. So I can see that the 3, 12, and 6 are all multiples of 3. Let's take out that GCF. All right, divided everything by 3. Certainly, if you had not done that step and you plugged the larger numbers into the quadratic formula, you still get the same answer. However, you just work every step of the way with numbers that are 3 times as big. So this is going to be the, it's definitely worth it to take the time to do that factoring step. All right, in this problem, the quadratic formula, and please have it memorized for the test. You almost always need it for the SAT. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And for this question, a is going to be 1. The coefficient of x squared, b is going to be 4, and c is going to be negative 2. And let's plug it in. So it's going to be negative 4 plus or minus the square root of 16 minus 4 times 1 times negative 2 all over 2. And that's negative 4 plus or minus the square root of 16 plus 8 all over 2. Negative 4 plus or minus the square root of 24 all over 2. Now I do have to simplify that square root of 24. I like it to do it like this. You make a little like factor tree. 2 times 12. 12 is 2 times 6. 6 is 2 times 3. And then you circle any pairs of prime factors. Well, here's a pair, 2 times 2. The 2 over here doesn't have another 2 to pair up with, so that's going to end up staying inside the square root. My 2 that I circled, I'm only going to bring one of them out. Remember, when you take the square root, 2 times 2 turns into just a single 2. So there's going to be 2 out front. And then here, this 2 times 2 is going to turn into a 6 that stays on the inside. So I will have negative 4 plus or minus 2 root 6 all over 2. And I can reduce this fraction because all 3 terms are even. So let's divide the 2 out of all 3 of these terms. And I will get negative 2 plus or minus the square root of 6. That's my final answer, and look, is a perfect match for option B.